Hello, this is your instructor, Dr. Todd Daniel. And this week, for week 14, we're going to be talking about making predictions using linear regression. Let's start with this example of the geyser Old Faithful. As we visit this geyser, we may become interested in some things that we can measure about it. We might want to know things like, when will the geyser erupt next? And we may want to know, how tall will the geyser be? Now, are those things that we can measure? Of course, we can measure time and we can measure height. But maybe we get really interested and we want to know about the relationship between those two variables. So we want to know, does the delay since the last eruption predict the height of the next eruption? And what would you think? If it's been a long time since the last eruption, we might think that the next one will be taller because the pressure has had more time to build up. Or maybe we want to know whether the height of the previous eruption predicts the height of the next eruption. If the last one was really tall, maybe the next one will be shorter. So we can measure two things, time and height. And we want to know something about the relationship between these variables and what each of them could predict about the other. Enter regression. Regression is a way of predicting an unknown y-score based on x-scores from a correlated variable. So what we do is we use correlation to establish the relationship between x and y, and then we use what we learned from the x-scores to predict y-scores that haven't happened yet. Now, you have had some familiarity with this. Let's say before college you took some kind of test, and the purpose of that test was to predict how well you would do in college. Because the college admission staff wants to know whether it's likely that you will be a successful candidate. So maybe you took the SAT, or perhaps you took the ACT. The scores on the SAT can predict grades in college. Now, do those SAT scores predict perfectly? No, of course not. There are some people who do really well on the SAT and may not do well in college, although that is pretty rare. And there are people who do poorly on the SAT and do better than expected in college. But overall, SAT scores do predict college grades. Therefore, if I know your SAT scores, I can make a prediction about what you will do in college, even though you haven't gone to college yet. Or perhaps I want to know who will be successful in this job. And what I do is I measure people who are successful on the job on a variety of variables. And to be really accurate, what I would do is measure people who are successful on the job and people who are not very successful on the job on those same variables. And then I find out what variables are most common among those who are successful on the job. When I develop my pre-employment test, I look for people who score on the pre-employment test the way that people who are already successful on the job score. So I want people who have similar scores on the pre-employment test as do the people who are already successful. Because then I would predict that high scores on my pre-employment test would predict success on the job. Now, is it going to predict perfectly? No, but it's a very good start for understanding prediction. Correlation and regression are used together because they are two parts of the same thing. We use correlation, or R, to summarize the relationship between two variables. We know the direction and the strength of that relationship. When one variable goes up, does the other variable go up, or does it go down? And how reliably are they related? If there is a very strong correlation, we would see that the relationship would happen much more frequently than if there was a weak correlation. Now, regression starts with the assumption that the relationship exists. And if so, we can use regression to predict other relationships between the variables, relationships that will probably occur in the future. So, of course, the stronger the correlation, the better predictor that x value is going to be of y values. And if there is no correlation between the variables, there's no point in doing a regression equation because there is no relationship between the variables. So then, what is regression? Regression uses a linear model. And what that means is that we collect data and we plot that data on an X and Y axis, and we're interested in how well those data match up to our model of a straight line. Mathematically, what we can do is measure the distances of each of the data points from the straight line and calculate, based on those distances, what essentially amounts to an average, a mean. And that mean, the average of all of the distances, is called a correlation coefficient. Now, that correlation coefficient is something that we learned about last week. But what we're going to do is, when we run a regression analysis, the first step is going to be to calculate a correlational coefficient, and then we're going to use that correlational coefficient to make predictions. We'll start simply with just two variables, but I'll also show you how we can do multiple regression. In other words, we can do regression with multiple variables, and that's when things start getting really interesting. So let's find out a little bit more about what regression is, talking about the regression line.